So at this point in the year, with only going over units 1 and 2 in Algebra 2, we have covered about, if you were to look at including the conversion chart and everything, we could get a 79 with the 24 questions that I had you guys circle. All right. So for the first one, like I said, I'm going to go through it with the calculator and then I'm going to go through it algebraically. So for the first one, it's literally just a store button. So I always pick 2.1 because it is a very random number. So 2.1 store in for X, hit enter. Okay. And now you're going to plug this in. So X to the is this little caret above the division symbol. So we're going to do 3/4. So alpha y equals option number 1, right? 3 on top, 4 on the bottom, and hit enter. So 1.7447 is our magic number. So I'm going to write this down. 1.74447. Okay, that's what I'm looking for. So then I plug each of the other ones in. So 4th root of x to the third, I hit math. To get 4th root, I'm going to have to hit option number 5. So let me just clear this real quick. Let me put the 4 in first, hit math. Again, option number 5. So now I have the 4th root of x to the third. Hit enter. So again, boom, there's the magic number, right? So choice number 1. For those of you that want to learn it the longer way, listen please. So the top number is my exponent. The bottom number is my root. Okay, so I'm going to write x to the third power because that's my exponent and it's the 4th root. Roots bottom left, top right. That's what we learned. Okay. All right. Question number 2 is not, and it's not a math question really, but if you want to know the answer for this, correct answer is number 3. If you got that right, we want to do the most random sample. So every fourth student is random and during each of the lunch periods makes the plan more appropriate. Okay. All right. For this question right here, there's 2 ways to do it. The first thing I look at is instead of just dividing this out, okay, I would definitely do the remainder theorem because here the remainder is -7. Here the remainder is 83. Here the remainder is 0. And here the remainder is 20. Right? So I do remainder theorem. So remainder theorem says opposite of +3. So x equals -3. So I'm going to take my calculator here. I'm going to store -3 in for x. -3 store x. Good. And then now I plug in the top part right here. So 2x to the third power, go over to the right, plus 7x squared minus 3x minus 25, hit enter, and that gives you the remainder, which is -7. So which one has a remainder of -7? The only one is choice 1. Done. Okay. Second way to do it is to actually divide this out. Watch the longer video to help you with that. All right. Question number 4, if you just want the answer for that, it's 13. I did not go over this yet. Question number 5. So this is low-key an Algebra 1 question. So if we have a function y equals h of x, so if I go over here and I go to y equals, and I were to put in my h of x, I'm just going to say is x squared, so x squared, and then over here it says which one is used to represent the graph below. So I'm going to do h of x, which is x squared minus 2, so x squared minus 2, and I want to see if my function gets flipped over the x-axis, right? That's exactly what's happening. This gets flipped over to the other side. So let's see if that does it. So if I hit graph, that's in blue is my first function. My second function is literally just moved down, okay? So it's not the first one. And then I plug each of them in. So this one right here says, if I go like this, I go back to my y equals. This one says I take my h of x minus 2, so I'm going to do x, so let me just clear this real quick. So I'm going to do parentheses, x minus 2, and then square that. And that, if I were to look at it, that also is not getting flipped over the x-axis. Whenever it feels like coming, there you go. That just moved to the right, so it's not the second one as well. If I plug this one in right here, the third one, so this means that I go over here, I leave my x squared alone, clear this and put a negative sign in front of my function, which is x squared. And let's see if that works. That's my original in blue. Does this get flipped over the x-axis? Boom. There we go. So the answer choice is 3. And again, how did I do that, right? Here's my original. I looked to see what happened to it. Doot. I picked a function that I know, y equals x squared, and I literally just plugged it in. All right. Question number 6. So, yes. So we're looking to see if p of 3 equals 0, it can be concluded that what happens. So let's go ahead and remember what we do, right? We set this equal to 0, so x plus 3 equals 0. Basically, we switch the sign, so x equals negative 3. They did not do that, okay? So this is out. If I do the opposite of this, of minus 3, I get x equals positive 3, which is what we did. And so if this number equals 0, then x minus 3 is a factor. This is true. The remainder is 0. Da, da, da. Okay, so we don't know any of this part right there. All right, so the solution to this, so the way I showed you how to do this is y1, y2, or you could store this in for this, hit enter, and see if you get 7. You could do it that way as well. I just try to do it the way that maybe makes the most sense, maybe is easier, I don't know. So I'm going to go over here, clear this, and I'm going to put in this under y1, so 5e, right, where's e? Right here, above the division symbol. It's also above the ln, so there's on the bottom left, above that is store, above that is ln, and then above the ln is e to the. So I'm going to hit second and the ln button, and now I get that, and that's going to be x plus 2 on the top, x plus 2. And then if I go down to y2, I'm going to plug in what's on the right side, which is just 7. So I'm going to go over here and put in 7. And then I'm going to graph it to see if I can figure out where they intersect. So that's the first one, looks like an exponential, and the second one is a red line. Perfect. And now I'm looking to see which one, where they intersect. So second, trace. Option number 5 is intersection. So I'm going to go until I get to the spot that they intersect at. So I'm going to find my little cursor thing. So keep going. There we go. Hit enter, 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 and it gives me this number. So now all I have to do is plug in each of these and see which one matches. So negative 1.66358. So negative 1.66358. Okay. So hopefully if I plug in my first one, let's see. So I have, let's clear this. So I have negative 2 plus ln, again, is above the store button. And then I do 7 divided by 5. So alpha y equals, option number 1, 7 over 5. Let's close those parentheses. You don't have to, but I will. And then perfect, right? It's the one that is, and if you look at it, it is the one that is closest to it. You can plug each of the other ones in, but I already know my answer. All right. Number 8 is straight calculator. Nobody cares if you can do this algebraically. Awesome. So you hit apps, the only purple button. Option on mine, it's option number 2. On yours, it might be 8 or 9. Some of yours is 0. It doesn't matter. Find polysymbol 2. And then you're going to press any key. I usually just hit enter. And now this is option number 2, simultaneous equation solver. So option number 2, you go over to 3 equations, 3 unknowns, hit enter, and then you hit next by hitting the graph. I usually leave my answers as a fraction. So hit graph, and then you're going to put in the numbers in front of the variables. So 1, 2, negative 1, 1. Okay, so I'm going to put this in. So 1, enter. Don't forget to hit enter. 2, enter. Negative 1, enter. 1, enter. And now I'm going to put in the second row. So negative 1, enter, negative 3, enter, 2, enter, 0, enter. And then now I'm putting in the last 2, enter, negative 4, enter, 1, enter, 10. Don't forget to hit enter after that. And then you're going to hit the graph button, which is solve, and it gives you your 3 answers. So we have 3, negative 1, and 0, and that is option 2. Okay. All right, question number 9. I didn't ask you to do this, but this is a It's literally just plugging numbers in. If you did it, the answer choice is option 3. Question number 10, I did ask you to do. So where is this minus this? What is that equal to? So you could have plugged this into the calculator. Let me show you how. Sure, why not? You could store a number in for x, and then plug this in minus this one, hit enter, and it gives you the answer. But I'm just going to walk through because this is an algebraic problem. So x minus 3 squared means I do x minus 3 times x minus 3. And then it says minus g of h, so minus x plus 3 squared is x plus 3 times x plus 3. So now I'm going to FOIL this, so I get x squared minus 3x minus 3x plus 9, okay? And then I put a minus sign, and this whole thing right here, when I FOIL this, I get x squared plus 3x plus 3x plus 9. And so combine these right here, so that's negative 6x plus 9 minus, and I have x squared plus 6x plus 9, okay? And then now I have an imaginary 1 here, so I'm going to distribute this. So I have negative x squared minus 6x minus 9, and this is x squared minus 6x plus 9. So the x squared minus x squared, they cancel. The positive 9, negative 9 cancels, and my answer is negative 12x, which is choice 3. All right, question number 11. So this is decreasing every, yeah. So you have a function here, and so if I take a look at it, the first number right here is my start, what I'm starting with. So it's starting with 50, which option number 2 says that. And then the next one says the mass of the carbon-14 is decreasing by half each year. And that is not true. What's happening here is it is decreasing by half every, whatever this number is on the bottom, 15 years. So option number 1 is not true, so the only one that is true is option number 2. If you didn't get that one, no biggie, right? That's one of the ones that either are hit or miss. This next one, though, you should all get. Okay, so over the interval 2 to 4. So 1, 2, right? My y is going to be 1, 2, 3, 4, 5, 6. So this point right here is 2 comma 6, and then I have to find the one for 4. So if I go over to 4, 1, 2, 3, 4, and this goes up to 10, so 4 comma 10, then you put in x1 y1 x2 y2, and then we put it into our formula, right? y2 minus y1 over x2 minus x1. So if I do that, 10 minus 6 over 4 minus 2, 10 minus 6 is 4, divided by 2 is equal to 2. So the slope from 2 to 4 is 2. Then I'm going to do the same thing on this side right here. And again, I'm looking from 2 to 4. So I'm going to do x1, y1, x2, y2. And so now I'm just plugging numbers in. So I have 3 minus negative 5 over 4 minus 2. And so this is going to be 8 divided by 2, which is equal to 4. So this is 4, and this one is 2. So which is true? G has an greater average rate of change. That's not true because that one is 2. The average rate of change are equal. No, the average rate of change for G is twice the average rate of change for T. So G is not twice as much as T, right? 2 is not twice as much as 4. The only one that makes sense is option number 4, right? The average rate of change for G is half the average rate of change for T. All right, we're doing good. Number 13, so always draw this. So it has a directrix of 3. So 1, 2, 3. This is where our directrix is, which is a line. So y equals 3, I just label it. And then the vertex is at 2 comma 1. So 1, 2, 1. So remember, whenever you're doing this, you always look halfway between. So halfway between 3 and 1 is 2. This is where our vertex is going to be. So this point is 2 comma, looks like 2 comma 2. Right? 2 comma 2. So that's first number is my H, second number is my K. So then my P is, right, this is one distance away from the focus to the vertex and one distance from the vertex to the directrix. So P is equal to 1. And now I have to decide if it's going to be positive 1 or negative 1. Since our graph can never cross the directrix, it's going to have to be towards the focus, which is down. So our P is going to be negative 1. And then we plug it into our formula, right? Y, this is the formula. You need to have this memorized. Y equals 1 over 4P, H minus X minus H squared plus K. And now all I'm doing is plugging some numbers in. So Y equals 1 over, oh, they tricked me. Corn chip, hold on, reverse. Okay, they tricked me. So see, it can happen if we're not reading. So they told us, all right, let me check this out. They told us that the vertex is 2, 1. The vertex is at 2, 1. That's our vertex. So our focus is going to be the same distance to the bottom. So this is from the vertex to the directrix. That's 1, 2, right? So that my focus is going to be 1, 2. So it's going to be right here at 2 comma negative 1. So 2 comma negative 1 is going to be my focus. And that's answer choice 1. See, they tricked me. They had me doing more work than I need to. Done. All right, this one right here, I did not teach you this, but I wrote a note to teach because it's actually very easy. So this is called normal distribution. So I'm going to go to my calculator here. You see the clear button? First of all, let me turn the calculator on. Come on, Berkey's, turn the calculator on. And then we're going to quit this, which is option number 6. All right, let's clear the screen. Good. All right, so there is a clear button, okay, above the little mountain symbol, below the down arrow. To the left of it, there's a vars button, and above that in blue is DISTR. So to get there, I hit second vars, and now I'll get to this screen right here. So what we're going to do with this is always going to be, and again, I'm just telling you this. So this is normal PDF, which is option number 1. And then this is where you put in what we're looking for. So here, no, it's not. Hold on. Let me just, okay, I'm back. So it's not normal PDF, it's normal CDF. So again, same buttons, second vars, option number 2 is normal CDF. So then when you do that, you're going to get something that says lower, upper, this little U and this little O symbol. Let me just tell you what each of these are. So it says the heights of da-da-da. So we're looking for this right here. 65.5 is our U. So our U is 65.5. And again, like I said, if you get this, great. It's one more question closer. The O with the line over it is standard deviation, and they tell us that that is 2.9. So this is our little O symbol. This is our lower. This is our upper. Let me just write upper. So now I just plug this in. So my lower is 64. Hit enter. My upper is 68. Hit enter. My mean is that little U symbol, which is 65.5. Hit enter. And then our O with the little line over it is our standard deviation, which is 2.9. So this is now going to give me a percent as specifically as a decimal. So I'm just going to hit enter, enter, and enter again. So now this is 0.531 blah, blah, blah. Okay. So now this is the percent, right? Specifically as a decimal. So they're telling us that the heights of the total number of students is 3,300. So we're going to take this number and multiply it by 3,300. If they didn't say how many people or how many students and they just said what is the percent, you'd be done. But since they said how many students, so that's 1660. And like I said, if you get that, great. If you don't, no big deal. All right. Question number 15, which one is true? So all you have to do with this question is graph it. So go to y equals, clear everything that's there. Okay, how do you get that? So the negative sign is under the 3, negative. To get log, there's no number underneath log, so we're just going to hit above on, there's store, above store, there's ln, above that, there's log, and then I'm going to put in the x plus 4, close parentheses, and then I have a plus 2. So now it's asking me which one is true, so I'm just going to hit graph. So it seems like, all right. So it says f of x, which is y, has a y-intercept at 0, 2. So y-intercept, does that go through 0, 2? Let's see. I'm going to hit second graph for my table, whenever it feels like working. There we go. I don't have 0, 2, so that's out. It says negative f of x has a y-intercept at 0, 2. So remember what the negative sign does in the question that we did before with the h thingy thing thing. This one right here. Remember the negative sign in front flips it over the x-axis. So as I look at the question right now, and I go back here, that is also not true. Yeah, that's not true. It's not going to be at 0, 2. So that is out. And then this next one says, as x approaches infinity, which means if I go back to my calculator, as I go to the right, as x goes to the right, which is where infinity is, it's saying that y goes to infinity. Is the graph going up or down as we go to the right? It's going down. That is not true. And the last one says, as x approaches negative 4, so let's see. There's my calculator. As we go to negative 4, what's happening to y? Y is going up. So you can't see past that point, but what's happening is it continuously goes kind of like this, and then it tapers off. So option number 4 is the only one that's correct. Question number 16, that as soon as you see there's going to be like some sort of experiment, right? Non-room darkening shades, I wrote next to it. Question number 17, if you did it, the answer is number 2. We're going to skip that for right now. This can be rewritten as, right? As soon as you see the word equivalent or rewritten as or is the same as, you can use the store button. So how do you use the store button for this, right? Just like before, I'm going to store in 2.1, store x, hit enter, and then I'm going to plug in the expression. So alpha y equals option number 1, and then I'm going to put in x squared, right, plus 12 on the top, and on the bottom I'm going to put x squared plus 3. So that's our magic number. Did I do that right? Yes. And then I'm going to see which one matches that. So if I do alpha y equals option number 1, clear that. Alpha y equals, I said, option number 1. If I put 10 on top, hit enter. Wait, go to. I didn't put the bottom part. And then on the bottom is x squared plus 3. And again, I have to get the number. Let's go up. I have to get the number 2.21, and that's not the same thing. So 2.21 is our magic number. So it's not number 1. If I go to number 2 and I plug that in, then again, all I'm doing is I'm matching to see if I can get 2.21. So I have 1 plus, and now I do the alpha y equals to get the fraction. Option number 1, put the 9 on top, and then the x squared plus 3, hit enter, and boom. So my answer is option number 2. All right, that's question number 18. 19, never did, but if you tried it, 20 is 4. Like I said, we didn't go over those. Don't worry about it. This next one, low-key, is from Algebra 1. So I just want to refresh your memory. AN is your current term. AN minus 1 is our previous term. And AN plus 1 is my next term. Okay. So it's saying a function is defined as AN, which is current, equals AN minus 1 is previous, plus log of n plus 1, parentheses n minus 1. And then they're saying A1 equals 8. So we're starting, we have A1, A2, A3. So here's A1, here's A2, and here's A3. They're telling us that A1 is 8. That means that 8 goes there. So to find A2, right, we have to follow the rule, right? Take the previous number, which is 8, plus, then we do log, and on the bottom we have n plus 1, so our n here is 2, n equals 2 here. So I do 2 plus 1, which is 3, parentheses, n minus 1, which is 2 minus 1. So now I take this baby right here that I just wrote, and I plug it into my calculator, so 8 plus, and then I have log, but now see, look, this log doesn't allow me to put this number right here at the bottom, so I'm just going to go ahead and clear that. Let's put 8 plus again, and then to get the log where I can put the number at the bottom, hit math, go all the way down to log base, and this is where you put 2 plus 1, which is 3, and then over here 2 minus 1, which is 1, and I hit enter. So that means that this next number is going to give me 8. So I have, this number is 8. So I have an 8 here and an 8 here. And then now I'm going to do the same thing, right? Take it and plug it in here. So now I do, to get A3, I do 8 plus log of, right? On the number on the bottom, I do 3 plus 1 parentheses n minus 1. So 3 minus 1. And now this becomes again a calculator question. Just stay with me real quick. I'm going to go up here, grab that because it's still 8 plus. Now instead of the 3 at the bottom, I'm going to put in the number 4 because 3 plus 1 is 4. And instead of 1, 3 minus 1 is equal to 2. So I'm going to put a 2 in here. And then I have 8.5 is my third term. So this number is going to equal 8.5, which is choice 2. And again, like I said, if you didn't get that completely, that's a throwback from Algebra 1. Next one, which one has a maximum of y value of 4? This one has a maximum y value of 4 and a midline of y equals 1, which means it cuts the graph in half. But this one keeps going, so there is no midline, so it's not number 1. This one doesn't have a max of 4 because the arrows mean that it keeps on going, so it's not 3. And then I plug each of these in, and the correct one is going to be option number 2, but let me just show you why. So let me go to y equals here, clear what's there. And so I just plugged in the -3 cosine x, close parentheses, plus 1. And this does look like it has a maximum of 4. And my midline is 1. Is that true? So this is -1. Yeah, my midline is 1. So that is correct. And just so you know, the mode on my calculator is in radians because none of this says degrees, so I'm just going to leave it in radians. Okay. All right. Question number 23 is also a calculator. So this is how I do number 23. So let me clear what's there. I'm going to take my 2.1, my trusty 2.1, store it in for x. I'm going to pick a different number for y. So 5.2. I don't know why I chose that. Store that in for y. So alpha, right, 1. So now I have two numbers in for x and y, and I'm going to match. So I'm plugging in the whole thing on the, so parentheses, right? I'm just going to do the first one, x plus y alpha, right? And then I have an I, so second decimal. That's the first one. Then I close parentheses, open up another one. And I have x squared minus x, forgive my dog playing with her little squeaky toy. And then I have an I, close parentheses. No, I don't close parentheses yet. Silly. Minus y alpha 1 squared. My dog is providing some comfort. All right. So now I have this weird number right here. So I'm going to write that number down. So 9.261 minus, and then I have 140.608i. 140.608i, and I plug each of the other ones in to see which one gives you the same one. And unfortunately, only the last one does. Okay. Question number 24. I think you're getting the point of this. So for this one, again, you're going to use the store button. I just use my x, which is still 2.1. Plug in this right here. So 500 parentheses 1.03 to the x. Hit enter, get that number, write it down, and then see which of these is the closest, and the correct one is option number 1. All right. All right, so now we have some part 2 questions. So question number 25, does this have imaginary solutions? So for this one, you're going to use the quadratic formula, so negative b plus or minus square root of b squared minus 4ac all over 2a, right? This is a formula about the story about the negative boy, but this is in your formula booklet. Anyway, so a is equal to 1, b is equal to negative 4, and c is equal to 13, okay? You're probably sick of me right now, but we have 30 minutes in. We're doing good so far. Let's keep going. So negative b, right? The opposite of negative 4 is 4, plus or minus square root b squared. So this is going to be negative 4. Don't forget to put that negative 4 in parentheses. We square it. Minus 4 times a, which is 1, times c, which is 13, all over 2 times a, which is 2 times 1. So now I'm going to go ahead and take my calculator. If my answer right here gives me a negative number, then the answer to this question is yes, they have imaginary solutions. So let's do it. So parentheses, negative 4, close parentheses, squared. Nope, I didn't close the parentheses. Portuguese, going too fast. Good. All right, then we do minus 4 times our a, which is 1, times our c, which is 13, and then I'm going to hit enter, right? So I get negative 36, which means that under the radical, I have negative 36. So that's going to give me, remember this, right? 4 plus or minus 6i, right? Because the square root of negative 36 is 6i divided by 2. This has imaginary solutions. So yes, you have to say yes, otherwise you will lose a point, all right? Question 28, we're going to leave alone for right now. Question 29. Remember to get all the denominators to be the same. So n squared, n squared. To get this to be n squared, we're going to multiply it by n. Whatever we do to the bottom, we do to the top. And now we're going to cancel out the denominators. So I have 2 plus 3 times n is 3n is equal to 4. Subtract 2 from both sides. So I get 3n is equal to 4 minus 2 is 2. Divide both sides by 3. So I get n equals 2 over 3. Done. If I plug it in, I'm not going to get any zeros, so I'm valid. All right, this one, whenever you have 4 terms, split it down the middle. So factor the left. So x to the third comes out. I can pull out even a negative sign right here. And then I have a 2x left in. This is going to be a minus 1. And I'm going to do the same thing here, right? 9 comes out, x comes out, and I'm going to have 2x minus 1. My dog is losing her mind. And now I see a 2x minus 1 and a 2x minus 1. So I'm going to write that down once and write down the left, the thing that's left over, right? 2x minus 1 goes away. So I have negative x to the third here. 2x minus 1 goes away because I already dealt with it. And I have a positive 9x here. All right, so we're in a good spot. And then here I can see that x comes out of both. So I can take that x out and factor it. So if I take an x out here, I have negative x squared plus 9. And over here I have 2x minus 1. So this is factored as much as possible, so is this. But this one can be rewritten as 9 minus x squared. And I can break that down further. Okay. So I notice that 9 is a perfect square and so is x squared. So I can double bubble that. So 3 plus x, 3 minus x. Everything else comes down. So 2x minus 1 here and an x here. And that is my answer factored completely. Skip 29. Number 30. This is determining the value of a. So remember, this is like the opposite of what I did before with the first question. So I'm going to rewrite this as 81, and then this is my root. So radicals go on the bottom. There's no exponent, there's an imaginary 1, so I can rewrite this as 81 to the 1/3. And then I have x to the, right, this is to the 15th power. The root is 3. I'm going to do the same thing with the y. So this is y to the 9th divided by 3 is a root. So 15 divided by 3 is 5. That's x to the 5th. 9 divided by 3 is 3. And 81 to the 1/3, right? I'm just going to put that into the calculator. So 81 to the 1/3. I'm being lazy right now, but oh no. What the corn? All right, so it's right. It's going to give me something that's a little weird. So I have to figure out another way to write this because if I look over here, the x to the fifth and the y to the third matches, but basically they want me to take this 81 to the 1/3 power and rewrite it with a 3 as a base. So let's figure this out. 3 to what exponent is going to give me 81? Let's see. So 3, let's take my calculator. Let's do 3 to the third. That should be 27. All right, and this is going to be 3. So it's going to be 3 to the fourth power. Let's try that. So 3 to the fourth power is 81. Okay. So, okay. Then it says, so this right here, this 81, I can substitute in 3 to the fourth power. And this whole thing is raised to the 1/3 power, x to the fifth, y to the third, right? So when I have a power to a power, I multiply that, remember? So there's going to be 3 to the 4/3, x to the fifth, y to the third. So they said this is equal to 3 to the a. So what's my, and then x to the fifth, y to the third. So what's my exponent here, right? My exponent here is 4/3. That means that a equals 4/3. Okay. So that is question number 30. Question 31 is a straight graph question. So I'm going to make sure my mode is in radians, which it is. So I'm going to plug in, go to y equals. Instead of my -3, I have to put in a 2. Let's delete this number. And then in the parentheses right here, I'm going to have to insert alpha y equals option number 1, right? So I'm going to have to insert my 1 over 2. And I have the half x, and instead of a +1, I'm going to put a +5. That came in handy. Now over here, I want to change my axis. So I want to go from 0 to 2 pi, right? So hit window, and I'm going to change my x here. So here's my x min is 0, and my x max is 2 pi. So I'm going to put 2, and then pi is above this little mountain symbol above the division. And then I scale, that means like what I'm going to go by. Let's say I'm going to go by every pi. So second this. Okay, so now I'm going to hit graph. So it looks like, all right, looks like it's just going to go straight down and kind of like curve a little bit. Okay, so if I want to be a little bit more specific, right, I know that this is 10, this is 0. So what is that number right there? So if I go second graph, across from 0, I see 7. Okay, so I'm going to go here 0, 0, 0. Let's see. 1, 2, 3, 4, 5, 6, 7, 8. Let's just say that this is 2 pi. Half of that is pi. So here's my pi. And then at 0, 7, right? 1, 2, 3, 4, 5, 6, 7. So I'm going to put a dot here. And it looks like it went from 0 to 2 pi. And then let me go back to my table. So I want to see what number is across 2 pi. So hit second and window, which is my table set. And I want to put in 2 second, right? So I'm putting in 2 pi here. And if I go to my table, across from 2 pi is the number 3. So that means that at 2 pi, I go to 1, 2, 3, and that's where it has to come down to. And if I want to see anything else, do I have any other whole numbers here? Well, this right here, it's not a whole number. All right, so it looks like it's just going to come down to like that. I should do that better. Let's go to the graph again so I can see it. Okay, so at pi, let's see what number is across from pi. So let me go to hit second, go right, put in pi and go to my graph. And across from pi is 5. So 1, 2, 3, 4, 5. Okay, this is enough to graph, and I go something like that. Done. That's 31. Question 32. We're almost done. All right, question 32, it says exponential regression. So to do that, I hit the stat button. So let me quit out of this. Clear stat, which is under delete. Option number 1 is edit. This is where I'm putting my numbers in. So, all right, so there is my numbers that I plugged in. And then I'm going to go to stat again, go over to calc. Now I want it to do something. It's already telling me it's an exponential regression. So I'm going to go down until I see xreg, and I see it right here at option 0. So you press that. L1 is the first set of data that you have. L2 works. There's no frequency. Hit enter, 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 and it gives you an equation. Okay. So now it says rounded to the nearest thousandths. So now all I have to do is plug in some numbers and do some rounding. So let's see. So if I take a look at this right here, it's going to be f of t, because that's my y. So f of t is equal to, so I'm taking my answer and rounding to the nearest thousandths, so 169.136. So 169.136. And then it says take my next number, which is our b, 0.971. So 0.971, and raise it to the, in this case, our x is t, so I put it to the t power. And that is my answer. All right, I rounded it correctly. All right, question 33 says graph these two. So plug both of them in, graph it. So I plugged them both in, the magic of television, I paused it, but my scale is off, right? So I need to go back to that negative 10 to 10, so hit zoom. Option number 6 is standard. So now it's going to graph it correctly, right? There you go, boom. And now I'm just going to go to my table and figure out what my actual points are. So there's the second one, perfect. So second graph, and now I'm going to be very exact, right? So I don't like this again, so go to second window. Let's start at 0 and go to my table again. So second graph. So this is easier, right? So 0, 0, that's the first point. And then you're going to graph each of them, right? So 0, 0. You know how to graph. I'm going to pause. So I just wanted to like unpause it real quick. So this looks like it's going to have something like this, right? Going to have like this, go to 0, curve down, and then go like that. And this, if I go back to my graph, to see what's happening here, right? This is going to curve. Let me take that out. It's going to curve 1, 2, 3. Let me just make sure that that point is right, right? 3, comma 0. Perfect. So now I'm going to just go ahead and put that again, right? Doot, doot, doot. Oh, you kind of get what I'm doing, right? Doot, doot, doot. Okay, there you go. And then I'm going to do the same thing with the second. So negative 5, let me just change the color so you can see it. So negative 1, 2, 3, 4, 5, and then I go up to over 1, right? Up to over 1, up to over 1, up to over 1. So you should be able to see where that is. You're going to draw that. Like, I ideally use a ruler, please. Don't do what I'm doing. And then it says state the number of solutions. So we're just looking to see how many times they meet. And they meet, right? 1, 2, 3 times. 3. It doesn't say what they are, so we don't really care. All right? Almost done. 36 was the last one I believe I told you to do. Yes. So 36, this one right here, they're telling you, they give you both of these. So let's move this y to the other side. So minus 5 cancels out. So I get y is equal to 2x minus 5. And so whatever I have for y, I'm going to plug it in here. So I have x squared plus, instead of y, let's plug in that 2x minus 5. This gets squared, and it equals 25. So let's FOIL this out. So I get x squared plus 2x minus 5 times 2x minus 5 equals 25. First, outer, inner, last. So 2x times 2x gives me 4x squared. 2x times negative 5 gives me negative 10x. I'm getting sloppy because I'm almost done. Minus 10x. And this is plus 25. Bring everything else down. So that's going to be an x squared plus, and this is equal to 25. So now I'm going to go ahead and combine some like terms. So I have x squared plus 4x squared, that's 5x squared. Negative 10x is negative 20x. And then plus 25 equals 25. All right. So let's subtract 25 from both sides. That allows us to cancel both of these out. This is what I mean, minus 25. So this cancels out, cancels out. So I get 5x squared minus 20 equals 0. All right. Um, 5 goes into both of these. I feel like I missed something. Oh, yeah, I did. This is an x, so that's minus 20x. So I'm going to pull out a 5 and an x. So I'm left with x minus 4 over here. And then I split both of these because I want to get the x by itself. So 5x equals 0. X minus 4 equals 0. Add 4 to both sides and you get x equals 4 is one answer. Divide both sides by 5 and you get x equals 0. All right, so 0, x equals 0, and x equals 4. So now I'm going to go back to my calculator right here, type in this. So to figure out what my y's are, oh, look, I already have the 2x minus 5, right? So now I'm looking for where x is 0 and where x is 4. So y equals 2x minus 5. Again, I'm plugging in my two answers, x equals 0 and x equals 4. If x equals 0, let me go to my table. My y across from that is negative 5. So y equals negative 5. If my x equals 4, across from 4 I see 3. Right? You see that? So across from 4 I see 3. Y equals 3. So my two answers are 0, comma, negative 5 and 4, comma, 3. All right. Done. Woo! All right, there is another video or videos that go into a little bit more detail. Um, this already took us 47 minutes for 24 questions. No biggie, you have 3 hours for the Regents. I'd rather have you do well, all right? Again, like I said, if you knew how to do all those 24 questions, you would be hitting almost an 80, 79 right now. All right, best wishes.